Hello and welcome back to integration. We are going to look at preparing to integrate. So just like when we worked through the differentiation work, the idea of differentiating, adding, multiplying by the power, reducing by the power by 1 is reasonably straightforward, but we can complicate that by introducing more complex questions using our National 5 powers and indices rules. So in the integration chapter, we can do the same. So all we're doing, remember guys, we're adding 1 to the power, dividing by the new power. So we do need to be secure in changing from positive indices to negative indices so we can integrate. So for example, 3 over x squared is 3x to the power negative 2. 1 over root x, 1 over x to the half is x to the power negative 1/2. 1 over 4x to the 5, so it's only the x to the power 5 that comes up here, is 1/4 x to the negative 5. 5 over 4 multiplied by the cube root of x squared. Remember here, top number's the power, bottom number's the root, so that would be x to the power negative 2/3, and the 5 and the 4 basically stay where they are, so it'll be 5/4 x to the power negative 2/3. Okay, so we're going to be using our indices rules, such as the ones here, to answer some of these questions. So question number 1, find the integral of dx over x squared for x not equal to 0. So for that, guys, why is the x not equal to 0 there? We cannot divide by 0, so we just need to state in the question to make it mathematically correct that x cannot be 0 there, because if we're dividing by 0, we cannot divide by 0. It's like saying how many zeros make 1. No matter how many zeros you have, you will not have enough zeros to make 1. So we just can't divide by 0, which you should know from the domain topic we done earlier on in the course. So we can think of dx over x squared as 1 multiplied by dx over x squared. So that would just be 1 over x squared dx. Now we cannot integrate with the function of x as the denominator, so we need to bring that up to make it x to the power negative 2 dx. Then from there, add 1 to the power, divide by the new power. So that'll be negative x to the power negative 1 plus c, because we need our constant of integration as always. And then as we started off with a positive index, a positive power, we should write that as negative 1 over x plus c. Question number 2. dx over root x, so again, that would just be 1 over root x dx, because we can think of dx as 1 multiplied by dx. So 1 over root x, so again, root x is x to the half. So we need to bring it from the denominator up to the numerator, so it'll be x to the power negative 1/2 dx, the integral of x to the power negative 1/2 dx. So add 1 to the power, divide by the new power. So negative 1/2 plus 1 is negative 1/2 plus 2/2, which will be x to the 1/2, divide by the new power, which is a half. Just written it over here, 1 divided by half is just 1 multiplied by 2, which is 2. So I have 2x to the half plus c, which is 2 root x plus c. Again, we started off in third format, so we should really finish off that way. Right, question 3. So 7 over 2p squared dp, so I'm going to integrate the p's here. Can't integrate until we have the p's as the numerator, not the denominator. So we need to bring the p squared up, the 2 stays there. So it'll still be 7 over 2, it'll be p to the negative 2. Then add 1 to the power, divide by the new power. So that would be 7p to the negative 1 over negative 2 plus c. Again, constant of integration as always. And then p to the negative 1, we just move back down to the denominator, so negative 7 over 2p plus c. Okay, question 4 and 5 I will do in a separate video.